This is MATHguide.com, and my name is Mark Karadimos. In this video, we're going to derive the derivative of the sine function. So, strap yourself in, here we go. So, if we're going to take the derivative of the sine function, sometimes it's written like this, with the d dx. Okay, so if I'm taking the derivative of this function, how will it look? Well, it could look like, well, if I use the definition of the derivative, I don't have it posted, but by now we should be pretty deep into calculus that you should know this already, that we take the function and replace the function with x plus h, so subtract the original function and place that all over h. Now, of course, don't forget to keep putting this limit as h approaches 0. Okay, so this is really what we want to determine. All right, so I'm going to keep on rolling down, and I might have to write small if I really want to not take up that much room. Okay, now if I'm going to expand this, the sine of the quantity x plus h, you have to know a little trig, and it is sine, cosine, cosine, sine. And if you've had trig, you've seen that before. Okay, just using a little property of trigonometry. It's the sum rule. Okay, so here we've got this expression, just trying to use some properties to see what we could do with this. And now what I'd like to do is mess around with this algebraically. Like, for instance, I see a sine of x here and I see a sine of x here. So what I can do is I can take the sine of x out of those two expressions. In other words, I'm factoring, and if I were to factor that, imagine those two terms are next to each other, I would get the cosine of h minus 1. And then I still have this term, plus cosine of x sine h all over h. Okay, hard to draw straight lines with the tablet, so you'll have to excuse that. Okay, so moving along, I keep rewriting that limit as h approaches 0. Now, really what's happening here is I'm taking the limit of this sine of x cosine of h minus 1 all over h, and I'm also taking the limit of this as h approaches 0. Yikes, different size fonts. Yeah, doing it by hand, huh? That's the fun of it all. Okay, all over h. So what I'm doing is imagining is looking at this expression like two different fractions. Here's one fraction all over h, and here's another fraction over h. Just two fractions, and what I'm doing, of course, is I'm finding the limit of each one of those fractions. So the limit of the sum is the sum of the limits. Okay, so I'm using more properties. Looks like an n here, but that is an h. All h is in the denominator. Okay, so I'm going to need more space, so I'm going to scroll down a little bit. Might have to keep on doing this, because sometimes the math here gets a little fun. And let's deal with this first limit. Okay, so here I've got the sine of x. Notice how this has nothing to do with the h, right? That is the variable that we're allowing to drift closer and closer to h. Now, the sine of x has nothing to do with it, h, so I could take that factor out of the limit. Okay, then I have the limit of this, of cosine of h minus 1 all over h. And of course, that's the limit as h approaches 0. And again, we're going to do the same thing over here. So let's see, the cosine of x can come out of the limit. And what's left? I get sine of h over h. All right, well, now it's my job to convince you of how to clean this up. Okay, so I'm going to try to convince you as to how that's done. Let's start with the easy parts. Okay, so I know it's the sine of x times this limit plus the cosine of x times this limit. Okay, now the question is, what are these limits? Okay, this one's an easy one. We've seen this one many times. This one comes up, and it comes up when we start talking limits. And I popped up the graph there. And if you look at the graph of that function and you allow the function to get closer and closer to 0, so you'll see that you're approaching a spot which makes it easy to determine that the limit is approaching 1. Okay, it's right there in that graph. Take a look. I'll point to it. There you go. So I know it's approaching 1. It says so right there in that graph. Okay, now let's go back over here. Let's take a look. And by the way, you should know this without looking at the graph, because this is kind of a common limit that comes up. Anyhow, the graph really does help. So if you were to take this and graph it, put it in a graphing calculator, there it is. And you could see that if we allow h to approach 0, that the function itself, this whole function approaches 0. All right, so what does this mean? It means that I have 0 times the sine, that's 0, and I've got cosine times 1, that's cosine. Cosine plus 0 is just cosine. Okay, so there you go. So if you take the derivative of the sine function, it's equal to the cosine function. Okay, and it's also easy to see when you put the two graphs together at an intuitive level, it should look like they are. Okay, so there you have it. So please make sure you like the video. Make sure you also subscribe to the channel. Go back to MATHguide.com. Check out all our hundreds of lessons, interactive quizzes, and of course our instructional videos. Take care.